So, hope everybody can see my screen. Um, so the types of clouds really are three broad categories. One is infrastructure as a service cloud, which is essentially the ability to provision compute, network, and storage resources on demand. And good popular platforms in this particular category are Amazon Web Services and, let's say, Rackspace Cloud. And the second one is platform as a service, where there might be different types of platform as a service. There might be a development platform, let's say like Heroku, which is Ruby on Rails platform, or Azure, which is a .NET platform. That's how they started off, and they've kind of branched off into doing infrastructure service as well. Or let's say SpringSource, which has been acquired by VMware, is a Java development framework. And there might be just other specific platforms which are application specific, like RDS, which is relational database service from Amazon, which is just a MySQL pre-configured instance that you can get, which is backed up and snapshotted, and you can restore from it, etc. There could be like a big data platform. Let's say United Layer provides a big data platform, and you could layer it on top of just open source Hadoop or some other distributions, it's like Cloudera. Or you might have a social media platform like Facebook or Twitter, and those platforms can be used for different business reasons in terms of being able to reach that particular audience. A third type of cloud is software as a service, and this is probably the most kind of used platform that people are kind of gravitate to, and the most popular in this is let's say Salesforce, where you use that as software as a service. But there are other software that started off as let's say installed on a particular server, but have kind of transitioned into SaaS model. Things like say QuickBooks or TurboTax, or even let's say some bigger enterprise type operations such as Workdays. PeopleSoft started off as a server deployment, and now Workday is trying to make the same thing as software as a service. There are other platforms that are essentially what they call software as a service, but underlying it's really they're trying to provide like an infrastructure. Things like Dropbox or Flickr. It's really at the crux of it is really storage, but you do that at a high level of abstraction where it's either application specific. Let's say Flickr, you're trying to store photos, but you really be able to interact with that through that one particular user interface. And then you have private clouds, which can be its own category, where you can take some features of deploy infrastructure as a service, or software as a service, or platform as a service. So these are the different types of cloud. So the next I'll talk about reasons for using each type of cloud service. And essentially for infrastructure as a service, some of the reasons are very obvious. One is the ability to have month-to-month or hour-to-hour type billing, and that means that usually there are no long-term contracts, and that might be useful for a particular corporation. Another reason might be that you don't want to take the scarce capital and put it on getting CapEx versus being able to use that money for other reasons in operations or headcount, etc. Another reason might be the ease of provisioning, or the ability to provision different types of operating systems for your application that might be offered by a particular cloud provider. And scalability, it's a really good reason where you might be able to scale up capacity on demand for a workload that you might have a particular use case for to scale up. Metered billing is another important reason. So this is important for people where they want to buy kind of a fractional type of a resource, and also they have the ability to understand how a resource is being used. For example, an application might want only 10 gigabyte of iSCSI SAN. Well, you really cannot go out and get a system with only 10 gigabytes of iSCSI, and you want to be able to you have to have like a maximum minimum when you go out and buy a system. Or you might want to, the cloud service provider might be billing you on resource utilization for various types of usage within a system. Let's say you're allowed only, let's say, 10,000 IOPS or a million IOPS per month. And knowing what your application is doing and how it's being billed is an important insight into how the application is utilizing a particular resource, and you can optimize for that particular use. API integration is really important sometimes from an orchestration point of view. Cloud service, infrastructure service providers provide an API so that your application can use that either to, let's say, scale something or, attach a device that might need to be attached for a particular use case so that you don't have to kind of do it manually. For a platform as a service, depending on the type of platform, there are different reasons to be able to use the platform. If you're using a software development platform, the ability to say that, look, I have consistent libraries that particular platform provides, so I need to be able to use that. So let me use a software development platform like, let's say, Heroku or .NET, so that I know what libraries are available to me, and it's consistent across different geographically distributed development teams. And I can also do a single application development framework around this platform that has consistent libraries is a good reason to use that. And another thing might be that, look, I really only care about the platform. I don't worry about the underlying infrastructure in terms of getting the servers, putting together an operating system, installing the application, and tuning it and setting all that up. That might be another reason to use a platform as a service. And another reason is, let's say we talked about social media platforms, where you might want to reach an audience that is using that platform, let's say Twitter or Facebook. And in that case, you may want to use that platform to be able to reach that audience, and or your application may want to use that. Let's say it's a advertising application that wants to reach the Facebook audience, or you're trying to sell something which reaches the Facebook audience. That's something that you might be you want to use that platform as a service. And the next category, software as a service, is, as I mentioned earlier, like Salesforce. You may want to use that for on a variety of reasons. Some of the reasons might be, look, I want to be able to access this data from, especially for a traveling Salesforce, from anywhere that they are, and have a consistent single database where they can access this data over the web in a secure manner. That's one reason. I don't have to really worry about administering the software. It's all done by the software as a service provider. So the administration concerns are kind of gone away. So that might be another reason. There might be metered licensing that might be attractive. Of course, you have to do per user fee, or I may have a metered license for a number of API calls I can make to this particular software. And knowing that kind of granularity and the ability to be able to be metered and paying for that particular service is attractive. And software as a service typically has API that you can integrate into the rest of your business process. So the ability to integrate, let's say, your QuickBooks with your SaaS service, in case of Salesforce, let's say QuickBooks with Salesforce, or some other workflow with your Salesforce is really important. And another thing that's important, that's a really good reason to use SaaS platform is you really don't have to worry about software compatibility issues. Which version of software is one person using versus another version of software that another person is using, and when they generate data with one version, can you read it with another version of the software? So these are all good reasons to be able to use a SaaS platform. And like with any set of reasons that are good for a particular usage of a particular platform, people still, corporations still eschew public clouds, and that for a variety of reasons. And one of the reasons that people use people quote for not using a particular public cloud is security concerns, whether it's perceived or real. And they basically want to be able to know where a corporation may want to know where the trust zones are, and be able to articulate where these trust zones are, and they want to be able to provide this kind of a trust zone type audit to some of their compliance for the compliance and regulatory reasons. They also may want to be able to enforce a particular security model that's particular for their industry, and that they may not be able to enforce on a public cloud provider, whereas if you have a, let's say, a private cloud or a managed private cloud, you can work with a managed service provider to be able to say that, look, I want this particular security model enforced. This is a threat that's been identified recently, and we want to make sure that we enforce this within our private cloud deployment. And if for some reason, let's say the public cloud provider wants to be able to provide features for a large multi-tenant system, like putting in intrusion detection systems or other firewalling techniques, that actually may add to the cost of the public cloud, which then needs to be passed on to the customer, or adversely, it may actually affect performance because you may have inserted some other appliance or some other software in the data path, which in turn means that the performance of the application suffers. So the advantages are no longer applicable by using a public cloud. And speaking of performance, when you use a public cloud, there is usually a fixed menu of choices available, especially infrastructure as a service. And for your application, you may want to have a combination of different types of, let's say, deployment platforms. Maybe some workloads work great even they're virtualized, and some other workloads work really well when they are running on bare metal, without any hypervisor. Or you may discover that one particular workload can benefit from slightly more memory, but that particular CPU memory combination is not available. Or let's say a database workload, you require a subsystem that has really good I/O characteristics. Let's say you want SAS disks instead of SATA disks, or some sort of a Fusion I/O offload engine. So those are all kind of fine-tuning that may actually bring down the overall cost of the deployment, and that's something that translates to cost, and that might be another reason you may want to consider a private cloud deployment. And in terms of outage concerns, this is a real concern. Public cloud providers, you don't know where the data center is. They really typically don't disclose it for security reasons because they don't want to disclose it. But from a due diligence perspective, a corporation may want to know exactly where their workload is running, whether it's whether it's susceptible to earthquakes or floodplain or some sort of other attack vectors that they're not that's of concern to them. And also, if you're using a large public cloud provider and that entire service goes down, let's say Skype went down recently, and I believe Salesforce also went down, then you're just stuck. There's no transparency into exactly how they're bringing it up, or you really cannot talk to somebody. Whereas if you're working with, you have a private cloud deployment, or you're working with a managed service provider, then you may be able to have a one-on-one conversation and know what the status of the outage is. And more importantly, let's say when an outage is cleared, depending on your application, you may want to bring the application back to a known good state, or bring it up in a particular manner that you may want to have control over. So once the outage is resolved and it does come back up, you may want to be able to bring up your application in a manner that's very custom to your requirements. And that's also another reason where you may want to consider a public cloud may not give you that kind of a fine-grained control. And lock-in is always an issue. The ability to be able to migrate from one platform to another is really, you might want to do that for any number of reasons. And that topic I'll discuss again in the next slide, the types of lock-ins that you can get yourself into. One is an API lock-in, where let's say you have your application that's tightly integrated into a particular API from a service provider, either infrastructure as a service or platform as a service. and you want to migrate to a different service, well, there's a real opportunity cost involved in trying to rewrite your application to move to a different API, and there are obviously hidden pitfalls there as to when you rewrite the application, how do you test it, how do you know whether it's going to scale, all those things that you've already vetted out in the previous cloud service provider. The platform lock-in is could not necessarily is an API lock-in, but could be kind of a process lock-in. Let's say you're using Salesforce as a platform within your business process, but you may not necessarily have it integrated into their API, and everybody in your organization is using that platform. When you want to now move to, let's say, Sugar or Zoho or something like that, the cost, there's obviously a cost of moving all the data and the metadata that's on a particular platform to a different platform, and any inefficiencies that might be there, or you might lose the data. But another cost that really is hard to quantify is actually retraining your workforce to be able to use that new platform. And what is the cost involved in making sure that retraining happens, and what's the transition cost? So this needs to be considered before you want to be able to move to a different platform. So that inherently becomes like a platform lock-in or a process lock-in. A service lock-in is a little bit more subtle. Let's say you have a cloud service provider where, let's say, cloud provider 1 and or cloud provider 2. Cloud provider 1 has compute, storage service, and let's say they have, let's say, message queue service. And cloud provider 2 has only compute and storage service. But if your application is on cloud provider 1 and you've chosen to use the message queue service because it makes your application development easier, or you have taken advantage of the particular service provided by that particular cloud provider. Now you want to move to a different cloud service provider, even though they have compute and storage available, but they don't have this queuing service available. Even though you may not have integrated the API tightly and you can afford to make the change in the API, now you cannot move it unless you have to try to figure out how to deploy your own queuing service in the new cloud service provider. So that kind of becomes a service lock-in. So these are the different types of lock-ins that you might have within a cloud provider that you choose. So what's the real, what's the choice? It really depends on a number of factors. You might have a scarce capital. If you're a startup, you might be better off just using a public cloud, and then when you start getting more revenue, migrate to a private deployment, depending on whether you have a good handle on whether it's cheaper for you if you do a cost corridor analysis to move to a private deployment. Or you may do, if you are doing test and dev and you want a periodic scaling of capacity, let's say for 2 or 3 months for every 6 months, every half year, you may want to actually use a public cloud to do the test and dev, and when you actually do the deployment, deploy it on your private cloud. There might actually be capacity on demand reasons where you may want to have capacity for, let's say, 2 weeks for a particular event. Let's say, for example, the Mars landing from NASA. They probably estimated that they require a huge number of capacity for literally millions of hits for a short period of time, let's say 2 weeks. And after that, the existing capacity that they have in their data center can handle the load. Well, that's a great case for using a public cloud where they can really spin up a ton of web servers on the public cloud for that short period of time. And then when capacity settles down and the demand is kind of tapering down, their existing capacity can handle it. Really, the answer is you're better off kind of looking at trying to choose the best of both worlds, and hybrid model is probably the way to go. So in conclusion, there might be different reasons why you might use a public cloud depending on where you are in terms of, like say, capital allocation or the life cycle of the company in terms of how you want to allocate capital, or you're in a particular vertical that really values security and compliance and really cannot do anything in the public domain, so you may want to consider a private cloud. But there are advantages to using public cloud for other reasons like test and dev. You want instant scale and metered billing. And so it's really kind of really balancing the two and figuring out which factors are important for you within the life cycle of the organization. And where you might end up really is looking at a hybrid model, which works well for different use cases as you deploy your application or deliver your service. So that concludes the webinar. So I'm happy to take any questions that the audience may have. So a couple of questions of a hybrid approach. The question is, can you give a couple of examples of a hybrid approach? I think you mentioned this already, where let's say you have a private cloud deployment at a managed service provider, and you may want to use the public cloud for your test and development. You may want to be able to use the public cloud to do test and development, and once you're satisfied with the testing development, and maybe you want to do QA there as well, then you may want to move to a private cloud once you actually deploy the application. And another question is, what's the cost point that you typically see businesses moving to a private cloud from a public cloud, and then moving to a hybrid approach? So what we've seen, a couple of use cases. One use case is this company that's in the ad business, where they started off in a public cloud provider, and they saw their bill going up at about, let's say, $10,000 to $15,000 per month. And they also wanted in their application they were using a combination of a Hadoop deployment to mine the data and then respond to ads or bid for ads. So they, we worked with them to really characterize the performance of the application, and found out that they're better off going on a mix of virtual and bare metal deployment, as well as their Hadoop cluster. They really didn't need 10 gig. 1 gig was plenty enough for them, and they really wanted a lot more disks on their Hadoop cluster on each of their working nodes. So we really worked with them to understand what these application requirements are to be able to deliver the performance that they require, because the latency requirement was very important for them, and that really cost them real money in terms of dollars that they could. It actually went to their bottom line in terms of being able to respond to bid for ads. So we put them in a dedicated private cloud, and with a switch, their own private switch, so that their Hadoop cluster and the rest of their workload in the same broadcast domain. They've seen a really good performance increase, and at maybe 70% of the cost. And now they know they're on a different scaling curve, so that's a good cost point for them. A second company also started off deploying on a public cloud, and they also again hit about $15,000 per month. And we're also working with them currently to figure out a system, private cloud, that can really get to a different scaling and performance curve. So I think cost is always a factor when people try to figure out where they want to move their application or workload to, that we've seen so far. Anything else? I guess we're coming up on towards the end of the presentation here. So unless there are any other questions, we'll conclude the presentation. But you're happy to answer any questions. My email is mukund@unitedlayer.com. Thank you.